First thing we're going to look at is complex fractions. So now we have 4 layers of fractions and we want to get it down to 1 layer. So I'm just going to target the top of this fraction, and in order for me to create just one fraction on the top and one fraction on the bottom, I need common denominators. So I'm going to target each one, and then we'll figure out how to get it away from 4 layers of fractions. Okay, so my common denominator, I see that we have a y and an x. Those are not common, so we need one of each. So my new denominator on the top is going to be xy. And so now I can look back. I was missing an x from the first fraction, so I'm going to put an x here and an x on the top. So x times 3 is 3x. And for the second fraction, I was missing a y. So I'm going to multiply top and bottom by y. And so 7y on the top. Okay, on the bottom, I also see that we have a y and an x. Those are not the same. So I want one of each. So I have x times y on the bottom of both of these fractions. And I'm going to change this to plus and negative on this. So I have xy on this one. So I'm missing an x. So I'm going to multiply top and bottom by x. X times 1 is just x. And on this one I'm missing a y. So I'll multiply top and bottom by y. So that's minus 2y. All right, now I have common denominators. So I can add the top of the fraction and just keep my single denominator. So on the top of this, since xy is my denominator, on the top I have 3x plus 7y. Those are not common terms, so I just have to leave it as 3x plus 7y. And on the bottom, I have x plus a negative 2y, so x minus 2y on the bottom, on the top of the bottom, and then my common denominator is xy. So now I have 4 layers of fractions. That looks a little bit better. So I'm going to multiply by the reciprocal so I can get rid of this bottom layer of my fraction. And I have to do this on the top and the bottom. So when I do this on the bottom, the xy cancels and x minus 2y cancels because I cancel top to bottom. And then on the top, I also have some things that I can reduce. So the xy's will go, but remember, these factors are connected together by the addition and subtraction sign. So I only have 3x plus 7y on the top and x minus 2y on the bottom. Okay, one more thing that I want to show you is solving rational equations. So we've added, subtracted, multiplied, and divided, but we have not solved equations. And so there are a couple of different setups that we could see. So I want to show you 2 of those, and then we will focus on these a little bit more when I see you again. So let's start with 12 over x minus 4 equals 8. So when I have something like this, I can find common denominators, or I can clear the fraction. I'm going to give you guys the option to do either one. So if I'm finding common denominators, I would multiply top and bottom by x minus 4. So I have 12 over x minus 4 equals 8 times x minus 4 over x minus 4. All right, so I multiplied, this was 8 over 1. I multiplied top and bottom by x minus 4. All right, so when my denominators are the same, we can kind of ignore them and just focus on the numerator. So this sets up just this little equation that I can solve pretty quickly. I can multiply through by 8, and then add 32 and divide by 8. So I add 32 to both sides, and that's 44. and then divide both sides by 8. So x is 44 over 8. And if I divide top and bottom by 4, that would be 11 over 2. All right, so I'm also noticing 4 would make my denominator 0. So we know that x can't be 4. That would be kicked out of my domain to start with. So if I end up with 4 as an answer down here, we know that it's no solution. Or if I end up with multiple answers and one of them is 4, we would kick 4 out. Okay, so your other option is called clearing the fraction. So I'm going to go back to my original. And I'm going to multiply both sides by x minus 4 over 1 because that gets rid of the denominator. So it's kind of like cross multiplying. It is actually, you could cross multiply and get the same result. So now I have 12 equals 8 times x minus 4, which is the same thing that we have right here. So I will give you options on that, and we'll work a few more when I see you again as well. All right, let me show you one more. There we go. Well, maybe. So 4 over 3 times x plus 1 minus 12 over x squared minus 1 equals 1 over x minus 1. Okay, so I have to, we talked about this last week also, I have to make sure that everything is factored before I start this. So I'm going to go ahead and factor x squared minus 1, and that factors into x minus 1, x plus 1. And so now I'm going to compare all of my denominators and see, all right, what's the same and what's different? Well, I don't see a 3, so my new denominator is definitely going to need a 3. So I'm going to do greatest common factor over here. Actually, least common multiple or least common denominator. So I know we need a 3. We need an x plus 1. So that's common. Do you guys see that? There's an x plus 1, and an x minus 1. And that takes care of everything that we see. So we want to write down what they have in common, but also what they don't have in common. So 2 of the 3 have an x plus 1, so that's common to 2 of the 3, but not all 3 of them. And 2 of the 3 have an x minus 1, common to 2 of them, but not all 3. And then 3 is just one of them. All right, so this is called clearing the fraction, that last thing that I did on the last problem. And so we can clear the fraction if you like that method, but I would multiply this entire equation by my least common multiple, by 3 times x plus 1 times x minus 1. So I'm going to multiply everything by that. So 3 times x minus 1, x plus 1. I wrote it the other way, it doesn't matter. Multiplication is commutative. So I'm going to multiply that by, maybe, by 4 over 3 times x plus 1. Minus, multiply it again by the next term, so every term gets multiplied by this, 3 x minus 1, x plus 1, and then I have times 12 over x minus 1, x plus 1 equals 3 times x minus 1, x plus 1, multiplied by 1 over x minus 1. Okay, now we're ready. All right, so I'm going to reduce what I can, because this is multiplication, we can reduce. So I see an x plus 1 with this one, so that's gone. And then I also see a 3, so I can cancel both of those. That leaves me a factor of x minus 1 multiplied by 4 no denominator. So clearing the fractions means we should not end up with a denominator. All right, so x minus 1, x plus 1, those are gone. So now I have 3 multiplied by 12 equals x minus 1 will cancel. So I have 3 times x plus 1 multiplied by 1. So that's not going to change anything. We can put the times multiplied by 1 right here. If there were another number, it would change our result, but that's not going to have any effect. So 4x minus 4, when I multiply that through, minus 36 equals 1 times x plus 1 is just x plus 1, so 3x plus 3. Now I want to solve this equation. So I'm going to subtract 3x from both sides. Well, maybe. Come on. Subtract 3x from both sides. So I'm going to go ahead and put these two guys together. So x minus 40, it's negative 4 minus 36, it's negative 40, equals 3. Then I'm going to add 40 to both sides. So x is 43. All right, the other option to this is to find common denominators, which we would go through the same process that we did here, but instead of eliminating the fractions, we build them. So I would say, okay, well, this one needs an x minus 1, so I'd multiply this by x minus 1. This one needs a 3, so I'd multiply this by 3. This one needs a 3 and an x plus 1, so I'd multiply the top by 3, x plus 1. So can you see now the bottom is all the same, so I can ignore the bottom, and then I'm just going to work with the top, and so that ends up being what we have right here. So it takes about the same amount of time to do either one. You still have to find the least common multiple and all the things. So remember also that we want to notice what we would kick out. Like for this one, x can't be negative 1 or positive 1. We would kick those two numbers out of the domain. All right, so we will work on this more when I see you again. Talk to you guys soon.